Ever wonder how AI can learn new tasks so fast? The secret is transfer learning. Instead of training a model from zero, you start with one that's already been trained on a massive dataset. Think of it like hiring someone who already knows the basics. You just teach them the specifics. This approach saves time, resources, and often leads to better performance with less data. Transfer learning works best when your new task is similar to the original one. For example, a model trained to recognize animals can be fine-tuned to identify dog breeds. The early layers of the model detect general features like edges and shapes, which are useful across many tasks. You only need to retrain the final layers to specialize in your specific problem. There are two main strategies: feature extraction and fine-tuning. Feature extraction means you freeze the pre-trained layers and only train the new ones. Fine-tuning goes further. You unfreeze some of the pre-trained layers and retrain them slightly. Feature extraction is faster and safer, but fine-tuning can give better results if done carefully. Choose based on your data size and similarity to the original task. Popular pre-trained models are available for almost every domain. In computer vision, you've got ResNet, VGG, and EfficientNet. For natural language processing, there's BERT, GPT, and Roberta. These models are trained on huge datasets and are open source. You can load them with just a few lines of code using libraries like TensorFlow, PyTorch, or Hugging Face transformers. Let's say you want to classify tweets as positive or negative. Instead of training a model from scratch, you can use a pre-trained BERT model. You tokenize your tweets, feed them into BERT, and add a classification layer on top. With just a few epochs of training, you'll get impressive results, even with a small dataset. That's the power of transfer learning in NLP. But be careful. Transfer learning isn't magic. If your new task is too different from the original, the model might struggle. Also, overfitting can happen if you fine-tune too much on a small dataset. Always monitor validation loss and use techniques like dropout or early stopping. Transfer learning is powerful, but like any tool, it works best when used wisely. In summary, transfer learning lets you stand on the shoulders of AI giants. You get to reuse models trained on massive datasets and adapt them to your needs with minimal effort. Whether you're building an app, doing research, or just experimenting, it's a game changer. So next time you start a machine learning project, ask yourself, can I transfer instead of starting from scratch?